Shanmuga Perumal is a faculty member in the Department of Information Science and Technology, College of Engineering, Anna University, Chennai. He has more than 6 years of PG and UG teaching experience. He teaches multimedia communication and networks, mobile and pervasive computing, computer communications and networks, computer architecture, mobile computing, mobile networks, ad hoc and sensor networks, communication techniques, grid computing, programming and data structures, problem solving and C programming. He is a member in several board of exams that include IT Board of College of Engineering, Anna University, Chennai, and board examiner in CSE, Computer and Communication, MCA of National Engineering College, Tamil Nadu. He has delivered guest lectures in various engineering colleges of Tamil Nadu, including National Institute of Technical Teachers Training and Research. He has also attended faculty development programs, seminars, conferences, and workshops. He has many publications in international journals and international conferences. He has filed a patent in India and published his novel idea in the Indian Patent Journal. His research area includes wireless sensor networks, mobile communication, location-based services, and electricity power generation.
Welcome to UGC lecture series in computer science. The series of lectures cover mobile and pervasive computing. The lecture series cover cellular wireless networks, global system for mobile communication, GSM architecture, GSM protocols, connection establishment, frequency allocation in GSM network, GSM handover, security in GSM, and the general packet radio service, that is GPRS. Today's lecture is about handover. We know that any telecommunication network cannot cover the entire service region using the single cell. So, the space or the service area is divided into many service regions, and users will move from one service location to some other service location even after establishing the call. So, the GSM network should handle the mobility of users without disturbing the services. So, that mandatory service is referred as handover. We will learn the handover technology of GSM today. Single cell phone cells do not cover the whole service area. In any telecommunication network, a base station or a single base station cannot cover the entire service area. We have many reasons for this. One of the main reason, if the service provider is using the single base station, then all the mobile users have to make a connection to a single base station. So, they have to spend a lot of power. As the mobile devices are running on their own battery power, it is not possible to always contact the single base station that is located very far away. And if a single base station is used, for example, all the GSM users has to be connected with a single base station. So, once again the frequency reuse will not be possible. So, for many reasons, and also robustness, if we are using the single base station and if that base station is getting any problem, entire users will be affected. So, we have many problems, so that we are dividing the service region into number of sub regions, and we are installing many towers and many kind of networking devices to provide the service for various users. In the GSM network, 35 km in countryside and some 100 meter in cities is supported. In the countryside, the environment is not complex as in the city side, and also the traffic. But in case of cities, the traffic will be very high. So, the number of users will be very high. So, obviously the communication range or the load of the individual cell will be decreased. So, we have many reasons that influences the shape and the range of the individual cell phone communication range. So, to handle all the issues, the GSM systems require handover procedures. Handover is nothing but handing over all the informations about the users as the users are moved from one location to another location. without disturbing the services. The smaller cell size and the faster movement of a mobile station through the cells. If a cell size is very small, then the possibility of a user to move from that cell to another cell will be very easily, because as the cell size is very less, the diameter of that cell also will be reduced. So, easily the user can come out of that circle and he will be entering to the new communication range. And the next reason they are telling that the fast movement of the users. Even the service range is very larger, and if the users are traveling very quickly, then they can easily come out of that communication range. So, the smaller cell phone range as well as the faster movement of the users can cause the handover very often. More handovers of ongoing calls are required. So, in GSM network we have the two scenarios. The users either can move very fast or the communication cell will be very less because of the heavy load. So, often the network is expecting the handover, it has to handle the handover properly. The handover should not cause a cutoff, that is known as the call drop. Whatever may be, the users can move fast or the communication range will be very less, but the GSM network should not disturb, it should not cut any call. If it cutting the calls that is already established, then the performance of the service provider will be bad. So, the GSM standard aims at maximum handover duration of 60 milliseconds. The standard discovered nearly 40 reasons for the handover to be occurred, but we have major two reasons for the handover. The first one is the mobile station may move out of the range of a BTS, that is, a mobile station is connected with a base transceiver station. In the architecture, the mobile station is connected with a base transceiver station, that is nothing but the cellular tower, and that cell phone tower is connected with a base station controller, that is referred as BSC, and many BSCs are connected with the mobile switching center. This is the architecture of a GSM network. Now, a mobile phone may come out of a particular tower of a particular base station. In the base transceiver station, once again the BTS is a cell phone tower that may contain many sectorized antennas. So, individual sectorized antennas may cover various area. Now, within the single BTS, a mobile station can move from one antenna to some other antenna, that is referred as the users are moving within the BTS. The second reason, the mobile station may move out of an antenna. So, individual BTS has many sectorized antenna. Now, a user can move from one antenna to some other antenna. The mobile station may move out of the range of the BTS. Now, individual BTS has its own range. So, many BTSs are connected with the base station controller, that is BSC. Now, a mobile station may come out from one BTS to some other BTS. The received signal strength decreases continuously until it falls below the minimal requirements for communication. The term received signal strength is very important one, because the received signal strength is nothing but the strength of the signal that is received by the mobile station. If a mobile station is very far away from the tower, then the signal strength will be very weak. So, beyond certain level of the received signal strength, the communication will not be possible. So, the range or the strength of the received signal strength should be in some threshold value, then only the communication will be possible without any error. So, always the mobile station and the network will keep on measuring the signal strength. So, based on the signal strength, the handover decision will be taken. The error rate may grow due to the interference. And the next reason, if many mobile stations are connected with a single BTS, then sometimes there is a possibility of getting interference. So, interference between the channels. So, if interference rate is very high, then definitely we have many error rate. So, this will cause the handover. The distance to the BTS may be too high. The GSM promises the maximum of 35 km range for the individual BTS in the countryside. Now in such a scenarios, if the mobile station is making a call from the maximum distance between mobile station and the base transceiver station, then the error rate will be very high and it will cause the handover. All these effects may diminish the quality of the radio link and make radio transmission impossible. Because of the interference and because of the very high distance, the signal quality of the link will be very worst. So without the worst quality, the communication is not possible without getting the disturbance. And the handover due to the overload. If many users are connected with a single tower, then the particular load for the particular tower will be very high. So that itself can cause the handover. The wired infrastructure that includes mobile switching center and base station control can measure the traffic in the cells. So the mobile switching center and base station controller, they are able to measure the load of the individual cell. So how many users are connected and how long they are connected and what are all the frequency bands allocated to the individual users. So these kind of informations are keep on monitored by the mobile switching center as well as the base station controller. If the traffic of a cell is too high, then the network can shift some mobile stations to other cells with a lower load. In GSM, if a cell A is loaded very highly and the cell B is somewhat with a less load, then the GSM network can take a decision. So it can shift some of the load from the cell A to the cell B. So even though the users are not moving by themselves, the network can cause the handover. So that is the point to be noted here. Because of the overload, the network can shift the mobile stations to the possible nearby cell phone towers. So that can create the handover. So that is referred as handover, maybe due to the load balancing. Now the load balancing is done by the GSM network. So far we have learned what is a handover and what are all the reasons for the handover. Now based on the discussions, the GSM standard classified 4 type of handover scenarios. They are intra-cell handover, inter-cell intra-BSC handover, inter-BSC intra-MSC handover, and the fourth one is inter-MSC, that is inter-mobile switching center handover. Let us learn what is intra-cell handover. So intra-cell, that specifies within the cell. So individual cell is supported by the individual base transceiver station and each BTS has many sectorized antennas, depends on the location where they are providing the service. So within the BTS, a mobile station can move from one antenna to some other antenna. So within the BTS, that is referred as intra-cell handover. So within a cell, narrow band interference could make transmission at a certain frequency impossible. Many users are connected with a single antenna to the BTS. So now because of the local interference, the communication may be impossible. So at that time the network has to do some alternate solutions. So it will reallocate the frequencies and sometimes it will allocate some new frequency bands. So this is known as the intra-cell handover. Now the BSC couldn't decide to change the carrier frequency. So in these kind of local interference situations, the base station controller can take some decision. So it will preempt the already allocated frequency and it will allocate some new frequency bands to the users. So this is referred as intra-cell handover. Next type is inter-cell intra-BSC handover. Now many base transceiver stations or many BTSs are connected with a single BSC, that is base station controller. Now the mobile stations may move from one BTS to some other BTS, but within the BSC, that is referred as inter BTS and intra BSC, that is within the BSC but between various BTS, that is the cell phone towers. So the mobile station moves from one cell to another cell but stays within the control of the same base station controller. The base station controller then performs a handover, assigns a new radio channel in the new cell and release the old one. After making the handover, the old resources allocated to the mobile stations has to be reallocated for the future use. So, in the second case, the users are moving from one cell to another cell, but within the single basic or base station controller. Let us have a short break. We will continue our discussion after the break. Welcome back. Before the break, we were discussing about the two kind of handovers. So, the mobile users can move within the cell, or the mobile users can move from one cell to another cell. Now, let us start from the third handover scenario. Inter BSC intra MSC handover, that is inter base station controller and intra mobile switching center handover. A base station controller only controls a limited number of cells. Many towers or BTSs are connected to the BSC now. In some situations, the load of the individual base station controller may be very high. So, at that kind of situations, the mobile switching center will shift some of the mobile stations connected with the BSC to some other BSCs, some new BSCs. So, GSM also has to perform handovers between the cells controlled by the different base station controllers. So, this handover then has to be controlled by the MSC. So, here the point is to be noted is the users are moving from one base station controller to new base station controller, provided both the base station controllers are connected with the single mobile switching center. That is why it is referred as inter BSC, that is between the basic station controllers and within the single mobile switching center. And the last type is inter mobile switching center, within the various mobile switching center. Many users are connected with the cell phone tower, many cell phone towers are connected with the BSC, many BSCs are connected with the MSC. So, the GSM network may have many number of mobile switching center based on the location and the number of users. Now, the last scenario is the user is shifting or traveling from one mobile switching center to another mobile switching center. A handover could be required between two cells that belongs to the different MSCs. Now, both MSCs perform the handover together. Both MSCs, that new MSC as well as the old MSC, they will initiate the handover operation. So far we have discussed about the four possible scenarios of the handover. Now, let us map our discussions to the diagram. This diagram explains the four possible handover scenarios in the global system for mobile communication standard. Now, the hexagonal shape represents the individual cell phone tower range. The BTS is nothing but the base transceiver station, that is nothing but our cell phone tower. Here one cell is connected with one BTS and the second cell phone coverage is connected with the second BTS. Now, two BTS or the two cell phone towers are controlled by the single base station controller. Now, this is the third coverage region. That coverage region is connected with a separate tower and a separate BSC. Now, this is an MSC that controls two base station controllers, and in the fourth scenario, two different MSCs we have, and this is the cell that is controlled by the different tower and different base station controller with connected with the different mobile switching center. Now, in the first scenario, an user, this dashed arrow specifies the movement of the user. Now, the user is shifted or the user is moving within the cell. In the second scenario, the mobile station or the user is moving from one cell phone range to the next or the new cell phone range. In the third scenario, the user is moving from one coverage region or one cell phone tower range into another cell phone range, but now the towers are controlled by the single MSC but different base station controllers. And this is the fourth scenario. Here the user is moving from one location to the new location. Here the BTS is new, the BSC is new, and the mobile switching center is also new. From the diagram we can easily understand the four possible scenarios of the handover. To perform the handover, the network has to measure periodically about the link quality. So, mobile station and BTS both perform the periodic measurements of the downlink and uplink quality Uplink is nothing but the link that is connecting the mobile station to the network. The downlink is one that connects the base station to the mobile station. Now the quality of both uplink and downlink has to be measured periodically. From the measurements, they provide all the necessary information for a handover due to a weak link. If they encounter some weak link, then immediately they will make some report about the weak link and its characteristics to the network. So the link quality comprises signal level and bit error rate. So the signal strength as well as the bit error rate are measured, and that report will be sent to the network. Measurement reports are sent by the mobile stations about every half second. The reports contain the quality of link and the quality of certain channels in the neighboring cells also. Though the mobile station is connected with a particular base station, it can measure the quality of the nearby channels also. Now handover decision. So based on the measurement done by the MSC, it has to do some steps to initiate the handover operation. The received signal level while an mobile station moves away from one BTS to another BTS is measured. The old one is referred as BTS old and the new basic transceiver station is referred as BTS new. Now the handover decision does not depend on the actual value of the received signal strength, but it is depending on the average value. The decision has to be taken care based on the average value, not based on an exact value of the received signal strength. So this diagram explains the typical behavior of the received signal strength. Now this is the old cell phone tower, that is the mobile station is connected with the BTS now, and this is the new cell phone tower. Now the mobile station is moving in this direction, so the signal strength is keep on decreased. So as the mobile station is coming away from the base station, its signal strength is keep on decreased, and as the mobile station is moving towards a new BTS, its signal strength is keep on increasing. This is the handover margin. So this is the handover margin. So it is specified by the GSM network. At some point the mobile station and at some point the network will initiate the handover operation based on the handover margin. This is the direction of the mobile station. So the mobile station is moving from the old BTS to the new BTS. So the base station controller collects the values of bit error rate, signal levels from uplink and downlink from both the BTS as well as the mobile station. Then the base station controller calculates the average values and compares to the threshold. So the GSM networks, they have some handover margin that is known as threshold value. The measured values will be compared with the threshold value and the handover decisions will be taken. Handover margin is used by the GSM network to avoid the ping pong effect, that is unnecessarily the handover should not happen. If sometimes because of some environment factors the signal strength may be somewhat weak, though the though the distance is in the threshold value, sometimes at a fraction of second the received strength may be less. So the network should not immediately do the handover operation. So the network is maintaining some handover margin to avoid the ping pong effect. Now let us learn about a typical signal flow, about how the handover is happening. So first the mobile station sends its periodic measurements reports to the BTS old. So BTS old is nothing but the current cell phone tower connected to the mobile station. In the next step, the BTS old forwards these reports to the corresponding base station controller, that is also referred as old, as the BTS old is connected with the base station controller. So now the BTS will forward the information of MS along with its own measurement. So both the BTS will measure as well as the mobile station will measure the link quality. Now the report is combined and sent to the base station controller. Based on the values sent by the BTS and the current traffic conditions, the base station controller old may decide to perform a handover. Then the BSC old sends the message to the MSC, that is handover required. So now handover required is the message that is sent by the base station controller to the corresponding mobile switching center. Now the mobile switching center requests the resources needed for the handover from a new BSC. So the moment the MSC receives some reports and requests, that is handover required from its base station controller, it will immediately request the next base station controller to perform the handover. So, if enough resources like frequencies and time slots are available, then the new base station controller will activate the physical channel at the BTS new to prepare for the arrival of the MS. Even though the MSC is making the request to the new base station controller, if the resources are not available, then the handover cannot be performed. So, the new BSC will check the available resources like frequencies and time slots. So, based on that, it will activate the physical links, it will request its base station transceiver, so that that new tower will allocate, it will try to accommodate the new mobile station. Here now the mobile station is preparing the measurement report and it is sending to the old BTS. Now the old BTS will send a measurement report to the old BSC. So, based on that, now the BSC is initiating some handover operation. So, handover decision is initiated by sending the handover required. Now, the mobile switching center forwards this handover request to the new base station controller. So, it will check the available resources like frequencies and time slots. So, if all the required resources are available, that will make the BTS to accommodate the new mobile station. So, that is referred as channel activation. Now, the new BTS will give the channel activation acknowledgement to the BSC. So, the new BTS acknowledges the successful channel activation, that is the cell phone tower. Now, the new BSC acknowledges the handover request. So, it will give the acknowledgement to the mobile switching center. Now, the mobile switching center then issues a handover command that is forwarded to the mobile station. Now, the mobile station breaks its old radio link and accesses the new BTS. If all the resources are available, immediately the mobile switching center will give the command to the mobile station. Now, it is the duty of the mobile station to break the link with the old cell phone tower and it has to connect to the new cell phone tower. Now, the layer 2, that is data link layer, is established. Once the mobile station is provided with a command, the link 2 or the layer 2 will be activated. So, the flow control, error control, everything will be initiated in the second link layer. Also, the handover complete messages are sent from the BTS new. So, the new BTS will send a confirmation message. After finishing the handover, the mobile station should release the resources at the old BSC and the BTS. Now, once the mobile station is confirmed with the handover commands, it has to break all the old resources that availed from the old cell phone tower as well as old base station controller. Already we have learned that the new BTS is giving the channel activation acknowledgement, and now the new BSC is giving the acknowledgement signal for the handover request made by the mobile switching center. Now, this scenario, now we are in the signal flow during the inter BSC and intra MSC handover. So, we should understand that both the base station controllers are connected with a single MSC. Now, the mobile station is shifting from one BTS to another BTS as well as one BSC to another BSC, but all the BSCs and BTS are connected with a single MSC. So, now the mobile switching center is giving the handover command to the old BSC. Now, that old BSC will forward the handover command to the BTS old, as well as the BTS old is forwarding the handover command to the mobile station. So, the moment the handover command is received by the mobile station, it will break all the old connections and the new link is established between the mobile station to the new BTS. So, these are all known as the handover complete message. Now, the new BTS will send the handover complete message, it is forwarded to the MSC. So, the handover complete message will trigger the clear command. So, the clear commands are used to clear the old resources allocated by the old BTS as well as BSC. The mobile station should signal the successful handover using the handover complete messages as well as clear complete messages. By sending the handover complete message as well as clear complete message, the handover is coming to the end. So far we have discussed about the handover and 4 possible handover scenarios and the signal flow, what is happening while the handover is initiated. Now let us learn about some basic requirements about the handover. So more sophisticated handover mechanisms are needed for seamless handover between the different systems. Sometimes the GSM network can hand over its mobile station to some other networks. So some seamless handover is required without making some errors or without making the disturbance in the services. The handover should be handled. So handover from UMTS to GSM without service interruption must be possible. As we already mentioned, the seamless handover between wireless LANs and 2G, that is the global system for mobile communication, as well as 3G networks are required. This can be done using multi-mode mobile stations and more sophisticated roaming infrastructure. As the handover requirements are keep on increasing, we need, or the network providers need to provide some extra sophisticated multi-mode stations to handle the handovers properly. Let us summarize what you have learned today. Single cell phone cell do not cover the whole service area in the GSM network. Various environment factors influence the shape and range of the radio cell in GSM. Handover should not cause any call drop. Signal strength is measured to take the handover decisions. Mobile stations frequently send the signal measurement reports to the GSM network. Let us pose some questions for our understanding. List down the reasons for the handover in GSM. What is mean by handover margin? How does the received signal strength used in handover decision? Explain the signal flow of handover in inter-BSC and intra-MSC handover. Identify the 4 possible handover scenarios in GSM. With this we conclude our today's discussion. In the subsequent lectures, we will discuss about the GSM security and GPRS. Thank you.